So now what I'm going to discuss is something known as momentum. Now, momentum is equal to the mass times by the velocity. So we know that velocity is meters per second and mass is going to be measured in kilograms. So if you multiply both of these units, the units of momentum is going to be kilograms, meters per second. Now, what momentum does is it describes how much motion an object has relative to its mass. Just because something is going very fast, but if it has a small mass, it won't have much momentum. And as opposed, if something is very big, but going really slow, it might not have a great momentum, or it might have a really good momentum. It's kind of like thinking about this. Let's say I threw a ping pong at you. The ping pong is relatively light. It's not going to hurt you much. But if I chucked a large boulder and it doesn't go that fast, the boulder is going to pretty much cause a lot of damage. That's because it's going to have a lot of momentum. Why? Well, the boulder actually has a lot of mass. So momentum is taking into consideration both the mass and how fast an object is going. Now, there is something also known as the conservation of energy. Now, conservation of energy just means energy cannot be created nor destroyed. Just like momentum. Momentum cannot be created nor destroyed. Whatever momentum you have at the beginning is going to equal to the momentum at the end. And I'll go through this a lot more detail later on. But think about a gun. Initially, the bullet and the gun are not moving. So if the bullet is not moving, the gun is not moving, that means initially they have zero momentum. You fire the bullet is traveling. Now the bullet has momentum. But what you also notice is the recoil of the gun. So the gun going backwards also has momentum because it's moving backwards. It has a mass and it's moving backwards. This is moving forward. So one of them has a positive momentum, one of them has a negative momentum, and they both balance each other out and they create zero momentum. That is known as the conservation of energy. That is why these guns have a recoil, because you start with zero momentum at the beginning and you need zero momentum at the end. Now, you could maybe have some momentum in the beginning, but that momentum has to be equal to the momentum at the end. Now, you could also think about boxers. So boxers try and do sharp punches. They want to make the punch as fast as possible because if they increase the velocity of the punch, they could increase the momentum of the punch. Even though they might not weigh a lot of mass, if they can make the punch super fast, it's going to make a big impact because it has a lot of momentum. Just imagine it. And now I'll go slower. You notice the difference. My mass hasn't changed. The arm still has the same mass, but one is going quick and one is going slow. Momentum is a vector quantity, so it has size and it has direction. That's why you need to be careful with the velocity. You have to take into consideration velocity will be positive in one direction and negative in the other direction. So momentum could be positive in one direction and negative in the other direction. If I had an object that's 2 kilograms traveling 3 meters per second, its momentum is going to be mass times by velocity, which is equal to 6. And that is kilograms meters per second.